All right, check, check, mic check. All right, looks like we're good to go on the recording. Cool, let's hang out for a little bit, let people trickle in. Um, See some names online right now that I recognize and appreciate everyone being active in the Discord and sharing their work along the way. Pseudocode, seen a lot of good content on your end, so that's awesome to see. And Sue, thanks as always, kind of reviewing everyone when my bandwidth is kind of full up here. So I've got some good collaboration going here. All right. Also, props to finding Dune's, what do they call it? AI explainer. Fantastic tool. Anyone who hasn't seen it, pseudocode shared in the 101 cohort 5 Discord. Dune has this feature where you can go look at anyone's query and kind of hit this AI explain to me what's going on in this query, and most of the time, it's a very efficient at breaking down what is going on. So it's really helpful. One of the best things you can do to learn is view other people's code and try and understand what they're doing. And this tool kind of just streamlines that. If it's a really, really complex query, I notice sometimes it doesn't explain everything really well, but I don't think you guys are there yet. And definitely recommend checking out that tool and checking out what pseudocode posted in the Discord. All right, looks like we hit top of the hour. I'm gonna go ahead and get started. So today, for the most part, we're gonna be running through more applications, I would say. We're still gonna be using the building blocks that we learned in the last session, and we're gonna be adding to those building blocks. And then we're gonna look at a few real world applications, some real analyses that you might be asked to do. We'll dive into that a little bit. And I'm realizing that these sessions are taking a little bit longer than I'd hoped. So I think our last class, we are going to be diving more into raw data, how to decode that data, how to really parse through raw blockchain data when we're not using the easy tables. Was hoping to get to that today, but I don't want to rush things here. I think it's extremely important that we take it slow through these easy tables and learning the building blocks so that you guys have somewhere to get started. And then this last class, I'll go through sort of those really detailed, what I would call is a much more technical challenging. It's more understanding the blockchain and how to extract that data. So going to take it a little bit slower and just make sure you guys are getting the building blocks, and then we'll dive into that. All right, with that, let's get started. Share my screen. All right, we want to go here. Okay, so today we're going to be looking at um, another Ethereum table. So everything we've been doing has been Ethereum. We're going to stick with that. We don't want to overcomplicate it. We've been mainly working with these core easy tables, and we honestly only touched on a couple of these. There's a lot more to dive in here. Definitely recommend doing that on your own time. I'm going to show you what's beyond these core easy tables, and what we're going to look at is these DeFi tables. Now, DeFi, just kind of breaking things down as simple as possible. DeFi is just decentralized finance, and normally in a centralized finance world, you have when you want to exchange one asset for another, you have a centralized order book, and someone fills a specific order that you put in. So, say you want to buy this stock and you have this much cash, someone fills that order. Now, in decentralized finance, it's a little bit different. They use something called, we'll call it swaps. And in this case, you don't have a specific person filling that order. You actually have what's called a pool, which has basically large liquidity of both assets that you want to trade. And you put one asset into the pool, and the other asset that you want comes out. So from a high level, that's what it is, but I'll go into the details and then we're actually going to be querying this data and we're going to be looking at some really interesting stuff. So let's run through an example. Um, in one case, let's say I have ETH, and I see this new shiny token that everybody's talking about, and I want to go buy it. I mean, I want to be early, I want to buy it. I know the price is going to go up. So what I do is I take that ETH and I go to a protocol like Uniswap, and I say, hey, I want to exchange this much ETH for that new shiny token. And so what I do is I interact with Uniswap smart contract, and it swaps out the same basically USD value of ETH for the USD value of that asset. And let's dive into what that looks like. So what we're going to use here is this easy DEX swaps. This is a fantastic table. Put it here, and I'm going to start my query like this, like we always do. Okay, this table shows us a lot of really good information, and this is a breakdown of that swap that I just talked through. It shows us block number, block time, the transaction hash, which we know is important to dive deeper and analyze, origin from address, origin to contract address. Okay, and some more interesting stuff, the stuff we're going to be working with is the pool name. This is the pool that we're interacting with to exchange one asset for another to perform a swap. And we can see how much we're pushing in. So in our scenario, we'd be pushing in 0.22 ETH, and then we can see how much would be coming out, which we see whatever that new shiny token is, we get 13,700 or 1,376 of that token. All right, 1 second, gotta add a couple more people here. All right, so we're able to kind of see this swap kind of broken down and have this insight into this data. And we can see the sender, transaction 2, we can see what platform. So here we see that Uniswap platform is what we went through to perform that swap. All right. And then here we actually have the symbols. So here we can see we traded ETH. WETH is wrapped ETH, so it's a way to basically transact ETH. Since ETH is the native blockchain token, it's a little difficult, so we need to convert it to WETH. So just know whenever you see WETH, it has the same monetary value as ETH. It's just easier for protocols to interact with than ETH. And then UniBridge would be that new shiny token we got out. So if I want to start looking into this, one of the first things I do is I look at this table. I look at what data is available. But if this is my very first time looking at swaps and trying to understand what's going on, I'm probably completely lost. And the first thing I'm going to do is go to a protocol that does swaps like Uniswap. And I'm going to go to their documentation, and I'm going to be a sponge. I'm just going to start absorbing as much information as I can. And I'm going to walk you through sort of that process just so you guys kind of can start getting a feeling of going through that motions. So what I normally do is go to the protocol, and what I'm looking for is documentation. I'm looking for any details that kind of explain how their protocol works. So a white paper is a really good place to start. That usually has a lot of information, but it'll have everything that you need. And it can be a little overwhelming, especially I think in Uniswap's case, their white papers are pretty in depth here, and it gets pretty mathematical. So I want to see if, hey, okay, this is a good spot. I could start here, start reading this. But maybe they have some more like simplified documentation that I can kind of look through. Maybe I'll look at developers. What is Uniswap? This seems like a better place to start. Maybe they just have a nice breakdown, and they do. Let's see, they have, what is Uniswap, protocol concepts, swaps. That's what I'm dealing with today, so maybe let's look there. Perfect. They got kind of a breakdown in layman terms of what a swap is, and all the math removed, everything like that removed. This is a good spot for me to really start understanding what a swap is. And we're not going to read all this today. I think a lot of this is a lot more in depth than what we need to do. But just know that if we didn't have these easy tables, you would have to understand all of this, and you'd have to know all the details of the smart contract and how to extract that. So lucky for platforms like Flipside and Dune, we have these easy tables, these models already built, and all we have to do is get enough information, enough understanding of this protocol to then go back here and understand the type of data that's coming out. And again, my next step probably would be like, okay, I see, I have amount in, I have amount in unadjusted. I don't know what that is. So probably what I would do is go to the DBT docs and understand what each line item is. And I'm gonna streamline this for you guys because I already know what each line item is, but this is what I would be doing the very first time I'm analyzing something like this. Here, awesome definitions of what each one is. All right, let's start analyzing this data. What interesting insights can we find from here? All right, and I'm just pulling up another sheet. 1 second. Okay, so let's ask ourselves. There are specific pools that we swap into. Let's find which pool has the most swap volume. And this would be basically a metric saying, what is the most popular pool? What pool are the most people swapping into from a volume perspective? I think this is very interesting. You can then see probably what people are swapping the most. All right, so let's define this as the most volume. And then we'll look at this from an all-time perspective. We could also look at this from the last month. We could look at it from all of 2023. There's a lot of things we can do with this, but let's start simple and we can build on top of that. All right. Sorry, guys, I thought I fixed this, but I gotta let people in manually sometimes here, so sorry about these pauses. All right, fantastic. So we want to know what pool has the most volume. So if I'm looking at this table, easy deck swaps, what information it has, I know I want to know the pool. So here, pool name. That is one thing I want to know. So I'm going to put it there. I want that to be an output. Next, I want to know which pool has the most volume. So how do we break down volume? Volume is just a summation of the total USD value that has been swapped. So how I would define this is, we want volume. Okay, what is the equation for volume? It really is just, and let me find the value that we need from the table. All right, amount in USD. So we want to know the amount in USD for every single swap with each pool, and we want to sum it up. Okay, and then I'm gonna break that down even further. Just I want to make sure you guys understand this. So each time you swap something, you're doing it to a specific pool. And a swap has an amount in, I'm trading WETH in, and then an amount out. So I'm getting the same amount out. So if I sum up the total amount that has been swapped in, that'll give us the total volume that has flowed through this pool. Total volume. All right. And since we want to know this for each pool, and we're doing a summation by the pool, we have to do the group by pool name. Or also, as we saw previously, I can do column 1. All right. Let's see if this works. Let's just run this. This will give a lot of data. So I'm actually gonna put a limit here, limit 10. And let's just run this. I think one thing that I do, and I think is beneficial, is as you're building things out, just run it periodically to see what type of output you're getting, to understand and make sure you're on the right path. Now here I would say I know we're not finished, but running this will at least tell me, okay, I think I'm on the right path. Okay, here's what we're seeing. We're seeing the pool name. Awesome. We know we got that. That looks right. And we're seeing total volume. So these numbers look accurate. I got the right number of columns. I didn't get any errors. Okay, awesome. Let's go back to our question. What pool has the most volume? So right now, this is just outputting 10 random. We want to find the one that has the highest volume. So how we do that is we order by total volume descending. So just like we do in Excel where we'd sort, we're going to do that with our order by function. And we're going to order by total volume descending. Okay. Now here I'm gonna run it. I'm gonna test it. I feel like this is giving me some good data, and we're gonna limit it by just the top 10. So let's see what happens. Okay, that's unexpected. We're seeing empty data here basically, and this is just something you're gonna run into. I wasn't expecting this. Why is this happening? And a lot of this comes with just trial and error and understanding that these models, although a lot of quality assurance has been put into them, sometimes the data isn't always perfect. And here, nothing's wrong with it. But in actuality, what's happening is just some of these data, some of these columns just don't have an amount USD. It's blank. So if they swapped in 10 ETH or 10 new shiny token, this model doesn't have a USD value for that. And that happens a lot of times. There's just no way to quantify it. So it leaves a null value, it leaves a blank. So let's troubleshoot. What can we do to get rid of that and get back to our answer? So what I like to do here is put a where statement. So let's filter out these ones where we don't have any data. And let's just get rid of them. As you can see here, like Cape, Zard, like these are tokens that are very unknown. They don't have USD value, so I'm not too worried about them. I think let's get rid of them. Let's clean up our data. So how I'm going to do that is I'm going to put a filter, a where statement where I say the amount in USD is not null. So basically I'm saying any row where we don't have the USD data for, just remove it. So that is not null. And I know it seems like a double negative. It's a little hard to get your head around, but we could do the same thing where it is null, and that'll only show us ones where it is blank. But that's not the data we want. We want where it is not null. Now I think this should give us what we want. Awesome. That's it. That looks like the correct answer. Okay, so we had to do some troubleshooting, we had to do some building, but ultimately, we got to our answer. We can now see that this balancer Aave boosted pool is the highest volume. USDC WETH, second highest. DAI, USDC, USDT. These all, now what I'm doing right now is I'm reading these and I'm just doing a quick quality check kind of with my experience. These are all very common assets that I see being swapped all the time that always have daily significant volume from day traders or institutions or whatever it be. So these look accurate to me, and I think this is good enough to move forward with. All right. Now that we've answered that, let's kind of play around with it a little bit. Let's find some more data that we can find interesting to us. So we're seeing the pool name, and some of these have good labels. Uni v3, I'm assuming that's Uniswap. This one doesn't have any labels. I would like to know what protocol they're using. We saw earlier that Uniswap was one protocol that's used for swaps, but there's actually quite a few. And I'm going to run a quick side query here so that you can understand how many. Select a distinct platform from swaps. All right. So let's see how many unique platforms this model is pulling data from. All right. We got Shiba Swap, Pancake Swap, Prax. Okay, we have 19 different platforms. These are all different unique protocols, smart contracts that people can swap on. I will say Pancake Swap is a big one on BNB chain. Uniswap is by and far the largest one, so you're going to see that everywhere. Trader Joe is the biggest one on Avalanche. So these are all just common DEXs, decentralized exchanges where you can swap one asset for another. Okay, so let's take that information and let's bring it back up above. So I want to know not just what pool has the largest volume, but I want to know what associated platform that pool is associated to. So platform. All right, so now what we're doing here is we're saying do a group by the pool name and platform. So I have to add a 2 here. And then again, we're ordering by total volume. All right, let's see what this looks like. Gotta go over to results. Okay, cool, here we go. So now we're seeing these same pools, but now we've added on what platform they're associated to. So this one that wasn't named that well, we now see that it's associated with the current platform. And Uniswap dominating a lot of these top ones, V3 and then V2. Okay, I find this pretty interesting and just putting on my analysis hat, what what is interesting about this data? What can we think about? Maybe since we're seeing a lot of volume on these 10, maybe we want to provide liquidity so that we can get a portion of the fees. That's something maybe I would look into and I don't know, just getting the ideas flowing of what kind of information this would be useful for. And I do want to show you guys one last thing. So I want to show you how to use something that's called a case when statement. And basically what this allows you to do is to edit your data within the table. Now we've seen previously how you can use aliases to change the title of a column, but we haven't really seen how we can inline change the output of our data. And we'll run through an example. Maybe this isn't the best example, but you'll be able to see how to use case when. So I'm seeing this Uniswap v3 and I'm seeing Uniswap v2. And I just wanted to show Uniswap. I don't care about v2. I don't care about v3. And actually further down the line, this is going to mess up some of my data. So if it says Uniswap, I just want to show Uniswap. So what we're going to do here is instead of platform, I'm going to use case. And then I'm going to say when platform is equal to Uniswap v3. And this is a text, so I have to put quotes there, single quotes. And let's say just Uniswap. Okay, so that's one. So what this is saying is, hey, when I run through this code, when the platform is equal to Uniswap v3, just output Uniswap. And we'll see this when I run it. But the reason why I'm doing this is because I want to do this for Uniswap v2 as well. So you can add as many variations as you want. I'm going to do this. When platform is equal to Uniswap v2, then just output Uniswap. Else platform and sorry, formatting, gotta get that right. And as platform simple. All right, so this is the case statement. So running through it again, we're saying, hey, here's the case. When platform equals Uniswap v3, just output Uniswap. When platform equals Uniswap v2, just output Uniswap. Else, all the other possible millions of scenarios, just output platform. So just output the initial, like if it's balancer, none of these statements say to do anything, so just output platform. And then we're going to end it and then give it a new alias here. All right, so let's run that and see what it looks like. Awesome. So much simpler, a lot easier to read here. Uniswap, 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 balancer. So it only adjusted the ones where I told it to adjust it. So pretty powerful tool. Here we're using it to manipulate text. You can use it to do mathematical formulas. You can say, hey, when the volume's greater than 1 million, then say top 100. Or you can really do a lot of creative things here. And I think you will find yourself using this quite a bit. And if you see this in someone else's code, definitely take a second and understand why they're using it and maybe how you could use that in your own code. All right, I think we talked enough about Uniswap pools. Let's take another step into this. All right, so we looked at what pool has the highest volume. Let's come up with a new, actually I'm gonna Put a new one here. All right, new question. We're going to be using the same table. And 2 dashes here is a comment, so it's not part of the code. All right. What is the USDC volume over time? Okay, so USDC is a token, just like WETH, that we're swapping in for something else. So we want to see, oh, sorry, what is the USDC buy volume? Okay, so I had that backwards. Sorry about that. So we want to look at when people are buying USDC. So they're swapping one asset. It doesn't matter what it is. It could be thousands and thousands of assets, but at the end of the swap, they're swapping one asset in, and the output is USDC. So they're getting USDC back. So if you envision that as like a purchase, I want to purchase USDC. I give up something, in return, I get USDC. So that is the amount that I'm buying. And so let's look how we've analyzed that. So we get our select from, we're going to use the same table. All right. All right, so I'm going to, again, look at volume. And we defined volume earlier. What that is the amount out USD. So buy is out USD in this DEX table. In would be sell, because you're getting rid of it. You're putting it into the pool for something else. Buy, you're putting something else in, you're getting this in return. So the amount USD, and if we want volume, I'm going to do sum as total by volume. All right. So here I am just, again, taking steps to get to our answer. So here, what really this is telling us is the total buy volume across everything on all these dexes. And the next step I want to do is put a where statement where I only want to look at USDC. This would be looking at everything, every asset, everything. So we gotta filter this a little bit. Where amount, oh, wait, symbol out is equal to USDC. Okay, so the symbol out is something from this table, and it's in the documentation where it's saying, basically this is the token you're buying, and this is the symbol. And so this matches what our question is, so that's what it should give us. So I'm just gonna run this. I'm gonna see what it tells us. I'm gonna see if I'm on the right track here to answering our question. All right, that's a lot of volume. This is in USD, so we're seeing millions, billions, almost $500 billion. I mean, that is a lot, but it seems realistic to me. So I think I'm on the right track. USDC is one of the most popular assets, so yeah, okay, I think I'm on the right track here. All right, our next question, or leading through this question, is we want to know over time. So this is grand total. But now let's break it down by time. Let's say I want to know how much was bought each month. Okay, so we saw this in the last class. We want to use the time of purchase. And how this is defined in this table is block timestamp. All right. And since I'm summing, we're going to do a group by. And I want to know by each month, let's go with. So we got to do date, trunk, month, as month. All right, and then I need to add a group by here, group by month. Okay, so sum all of the volume by each month that transaction occurred. So let's run this and see what happens. Perfect. All right. Okay, so again, as an analyst, I'm looking at this. Numbers don't seem that far off, but this isn't very pleasing to the eye. I'm not getting a good, just quick understanding of what's happening. So when we're doing a time series like this, it's perfect for a graph. So let's look at, I'm going to do a bar graph since we have broken out by month. X-axis is going to be month, and then our Y will be total buy volume. Fantastic. Let's take a closer look at this. All right, there we go. Okay, so we see some significant uptrend. So it looks like zero buy volume in these months. Maybe this asset didn't exist yet. Maybe this first month where we're seeing volume is when the asset first started to exist. We could go look into that. It's something interesting, and I bet you that would verify what our data says. All right, and then we see some significant volume increases, very high. Yep, this is 2021 where I think valuations and speculation was going crazy. DeFi was really taking off. People were swapping a lot. Okay, so this all seems right. I like this. And we have some major spikes here. May '01 and November. So May and November, we're seeing some significant spikes. What I might want to look at is why is that? Why are these kind of outliers? And just fast forwarding, I can tell you the answer. I think May '01 was when FTX collapsed. This was a centralized exchange, centralized crypto exchange that collapsed and kind of created this, I guess, fear within the market. And a lot of people were selling their crypto for USDC, which is pegged to the US dollar. So this is actually very interesting. What we're seeing is when there was a huge collapse in the crypto economy, that a lot of people sold their crypto for USDC. And then we actually see it again here on November 1st. Wait, I think I have these backwards. I'm sorry. Luna was an asset that collapsed on May 1st. And then on November 1st, FTX was a centralized exchange that collapsed. And so you can see during these times of panic, when there's uncertainty in crypto, people are swapping to USDC, which is pegged to the dollar. So it's safe. You're no longer kind of speculating on assets. So some very interesting data we were able to get just by these couple lines of code. And then I bet you if we looked on March 1st, there was some event that occurred that caused a lot of people to swap. And actually, off the top of my head, I can almost tell you it is when an asset called, I think it was USDC. I think USDC depegged from the US dollar slightly, and that caused a lot of panic. And so people were swapping out and back into it. So yeah, almost what we see here is times of panic within the industry we're able to identify purely by looking at swaps to this asset. All right, a little bit of a history lesson mixed in with some data, on-chain data analytics. So very interesting. All right, let's get that back up. All right, we looked at swaps. We looked at a couple. We learned about case statements. We looked at swaps to a specific asset. So hopefully that covers just kind of analyzing DEXs on your own. In the homework, we're going to ask you to do a little bit of this with a little bit more detail. But what I want to move to now is some more realistic cases where you would be analyzing. And what I'm using here is a very specific, a venture capitalist had come to Slice Analytics and was asking for some market data so that they could understand basically on their end when to make investments and understand what protocols to invest in. And one of these questions, so I'll create a new query here. Get to this. All right, one of these questions was really understanding smart contract deployment patterns on dozens of different chains. So we're only going to look at Ethereum, but kind of the scope here was, hey, we want to see deployment trends over time on all these different blockchains. And really what that is to a lot of people is it's a proxy of understanding developer activity. It helps them understand where are people spending time building new protocols, building new infrastructure, just you interacting with the chain and building on it. Now, in a vacuum, that makes perfect sense. There's a lot of different reasons why people would deploy smart contracts, and it's our job to help filter out that noise. We'll save that for another day, but for now, we're just going to take a look at this high-level question of what are the deployment patterns over time on Ethereum. All right. Um, I just realized I haven't been checking the chat. If anything came in, let me know, guys. Yep, looks like I missed a couple. Yeah, you called it DPEG USDC. Nice call there, Andres. And everyone bought the dip. I wish I would have. A lot of people made some really good money. All right. All right. Sorry, Barry. I'm going to jump back to your question. It says, why do we need to put the second column also into the group by? And Zuka answered that. It said, yes, because the sum function was applied. You need to group by pool name and platform. Otherwise, the query doesn't work. That's a good question. Let's slow down and get back into that a little bit. All right. So where did we do that? Yep, I think we did that here. Let me just bring this back to platform. Okay. So anytime you're doing a group by, whatever column is not in the aggregate function. So here we have an aggregate function for this, and then we have two columns that are not aggregates. So we're saying sum the amount in USD grouped by the platform and pool name. So these two need to be in the group by. So here we say for every time a row has this and it has balancer, sum up all the rows and give me the volume. And same thing here. Every time the pool name is this and the platform name is this, sum up all of them. Now, there's a scenario where the pool name is this and the platform is curve. Then that's a different line and we'll sum up all the rows that match that. So if we just did pool name and got rid of, oh, sorry, I gotta get rid of this here too. It's not gonna run. So just pool name, why we only needed the group by one, because now we're just looking at pool name. Anytime there's a row with a pool name, sum up the volume. So in our scenario, I think most of the time the pool name and platform are gonna match 1-to-1. So it didn't change our numbers that much. But if I were to do pool name and let's do like block time. So that adds another column of complexity. And then here I'm gonna do date, trunk, month, block time as month. Okay, let's walk through this, what we're doing here. So we're saying every time there's a pool name, and I'm gonna run it while we're doing this. Every time there's a pool name, a row with a pool name, and every time there's a date with a matching month, sum up the volume. So in this case, all the rows that had a month in this month and had this pool name, sum it up. And same thing here. So this is why we're seeing not the same data, because now we're saying we want to look at it by month. So hopefully that helps. Definitely play around with these. Understanding group bys can be a little challenging. It definitely took me a couple times of like watching a video to see how they interact. Because a lot of times you'll have 6 columns and 6 aggregates, and it's just kind of hard to get your head around. So hopefully that gets you a step in the right direction. And yeah, definitely keep playing around those because they get harder and harder, but they're really powerful. All right, let's jump back. All right, we are gonna do some more. We're gonna take another step here. We're gonna use joins. So if anyone took the Intro to SQL class kind of in your own time, you probably saw this. This probably was a big chunk of what the class was, or what that class was. And it is going to be a lot of what you're doing when analyzing. So I'm going to show you one case of it. I would say it's used probably just as much as the group by. It comes in handy when you are joining a lot of different data from different areas. So it definitely is getting more intermediate here. So take your time, make sure you're understanding it. But just giving you a heads up, we're going to take another leap here into the SQL world. All right, so question is, what are the smart contract deployment patterns on Ethereum? If I was asked this, I would want to break this down even further. I would want to say, what specific data can we get that will show us patterns? So in my head, I'm really thinking, patterns are something that can occur over a range of let's say, time. Okay, so I want to look at maybe how many smart contracts were deployed per day over the last year or since the beginning of time. So I think that's how I would break down this question. We've seen a lot that we like to analyze things over time, and it really is beneficial in helping you understand patterns and react to them. So that's how I'm going to interpret this. I think there's a lot of ways you could kind of interpret this question, but let's simplify it. Let's start with that. All right, and we're going to go with select. Let me find this table that we want to use. All right, we're going to go back to core. All right, dim contracts. So we want to look at contract deployments. And when a contract is deployed on we're using Ethereum here, it is a smart contract and it looks a certain way on chain. There's a create function that we're able to look at all the transactions that have ever existed on Ethereum and isolate the ones that are contract creations. And we could do that through raw data. But again, we know that these platforms are awesome and they've already done this work for us. So they have this table here called dim contracts. And this is just a list of every single smart contract that exists. So we're going to use that. Go here. And let's get a little sneak peek into what type of data is available here. So we see they have the address. I'm very important, or I'm very interested in that. And we have when it was deployed, and we have the transaction hash that it was deployed on. And we can even see the creator address, the developer that deployed it. We can see name, symbol. This is all really good information. So let's take a look at this. Let's just do. Let's start simple. Let's do count distinct address. Okay, what's this going to give me? As total contracts deployed. Okay, and if I just run this, this is going to add up all the smart contracts that have ever been deployed on Ethereum. Let's run this. And this doesn't get us to where we want, but I think as you know, we want to just check, make sure this seems right. Yep, so 64 million smart contracts deployed. Yep, that seems right. So now we have the total number. Let's break it out like we do by, let's do day. Let's do date, trunk, day. And then what is the deployment time? Created, block, timestamp. As day. Okay. And then since we're doing a summation and aggregate here, we have to group by day. And then I'm going to order by, just to make the table look better, order by day, ascending. Oh, I forgot a comma. I do this all the time. Perfect. All right, let's graph this. So we can see Ethereum, the data goes all the way back to 2015, and that whole day, 20 were deployed, 67. So let's see what this looks like over time. Let's do an area chart, and we'll do day. And our y-axis will be the total contracts deployed. Now, I apologize. This is a bad habit. I'm really not fully defining these tables for you guys. I should be adding a title. I should be adding access. I should be doing all this. But for the sake of brevity and time, I just want to get this data out here and look at it. Okay, so this is interesting, but my first glance is this is kind of hard to see the trends. Maybe a day is way too refined. Maybe I want to see, let's go by week. Maybe that'll give us a little bit easier of a way to see trends. Week. And then I could write week here, or column one. Oh, where did I use day? Oh, all right. There we go. All right, a little bit better. And what happened there? Fix this. Okay, this is better. And actually, if I would do this again, I'd probably go to months, but this is giving me a little bit better. I can see it a little bit better. We're definitely seeing these spikes. Hey, what happened in 2018? Well, I know Ethereum price kind of skyrocketed and the demand for the network kind of grew. A lot of people were joining Ethereum, and then it crashed. And okay, it didn't crash as low as previous numbers. So people came and they didn't fully leave. They still kind of stuck around. They're building, deploying smart contracts, and then we see some significant spikes here. A lot of volume, or a lot of smart contracts being deployed, and then again it dipped down. And we're seeing a little bit more consistency here. It dipped down even more. Less developers deploying smart contracts, and we're kind of back again. So there seems to be this cycle. And if I wanted to look at this, I'd play around with this data, adjust the time frames a little bit, and see if I can find patterns. And what I would also do is not just look at Ethereum, I'd look at other chains. I'd look at Polygon, I'd look at Arbitrum, and what I'd be looking for would be growth in one and um, maybe a reduction in another when there's not a change in macro. So what I mean by that is, like, let's say right now would be a good time to look at a lot of different chains and see which ones people are deploying more smart contracts on. That would tell me that, okay, they're deploying a lot of smart contracts in Arbitrum. There's more developers, more people using that protocol. I would want to look into that a little bit more. And that's not always the case. This is just a first macro glance. Maybe there's something going on that chain that people are deploying a lot of smart contracts. So first step, this gives me something to look at. I'm seeing some trends here. But now I want to look a little bit deeper. I don't just want to know how many times a smart contract was deployed, because that someone could deploy the same smart contract a million times just for the sake of it, because it doesn't cost anything to deploy on some protocols. Now on Ethereum, it is expensive to deploy, so I don't expect to see that. But I still would want to analyze what are the cost of deploying and compare that to the trends of deploying. Because if it costs $1,000 on average to deploy a smart contract, and we're seeing a huge spike in smart contracts being deployed, that gives me more confidence that people are deploying real protocols because they're investing money to deploy that. Now, on the flip side, Polygon, it's very, very cheap to deploy smart contracts. Like I said, someone could deploy millions for 2 cents each time. If I look at that, that's not that convincing. I'm not convinced that there's real builders on the platform. It could just be noise, or it could be real builders. I have to look into that further. But using this metric of looking at the number of contracts deployed, and now we'll look at the cost that it takes to deploy, I think I'll have a better idea of which chains are really, really growing and which developers are spending time on. All right, so let's hide this. All right, okay, going to take a break here, catch up on these questions. Okay, thanks, Soup. Appreciate you answering these. Is there a way, if any, to confirm if the data I got are correct? That one is something you should always be doing. And if you hear me, I have some experience. I've looked at this data before. I've been in the industry for a while, so I have sort of a innate kind of ability to, it passes the sniff test, what I'll call it. But at the end of the day, if you're delivering valuable data or you're making investment decisions based on this, you should be validating that data. And there's a lot of ways you can do that. In some cases with Uniswap, if let's run through that example. I looked at Uniswap, I found a pool, and I saw the volume. Now, here's my own independent data that I pulled using Flipside. You could fact check it with Dune. You could run the same queries on Dune and verify that. And a lot of times, you could go to Uniswap and you could look at, let's see if they have it, research. Uniswap has a lot of really good data resources that they've built themselves, and I'm kind of blanking on where this is. Yeah, I'm blanking on it, but Uniswap actually has a whole data set that has their own data. Basically, what we're querying on Flipside, they have that on a dashboard, and you can check against that. And I see we got some more great recommendations. DeFi Llama is a fantastic resource that has completely open source data and metrics, specifically TVL is kind of their bread and butter. And then they have an open source GitHub that shows you how they're calculating TVL down to the code so that you can verify that you trust their data. And then Glassnode is another good one. Kind of list goes on. The thing is everybody has their own data. If it's open source, that's awesome. That means other people can vet it and tell them it's right or it's wrong. But everybody's kind of doing things their own way. So check one or two sources, make sure it seems close enough. And if that's the case, then usually I'm pretty confident in the data that Flipside has. But you will run into scenarios. I actually, over the weekend, was looking at which wallets had the most Ethereum balance or the most USD balance. And I just jumped on Flipside, I queried one of their easy tables, and I think one of like a pool had like a balance of like 10 quadrillion. And it didn't make sense. And I just know, okay, something might be off with the model here. I should look into this closer. But I just then ended up jumping to another resource. I actually just went to Etherscan. I didn't realize this, but they have a way to check, who the top ETH balance holders are, which is what I was looking for. Yeah, so kind of over time, you build these resources. Definitely recommend having a data bank of your own of resources you can go look at. And I'm gonna take a real quick break. This is a great segment to what I wanted to show you guys. So Primo Data is an analyst programmer. He builds all these open source content, and he recently came out with this as as part of like this 12 Days of Christmas data thing. And basically, what it is, it's an entire overview of the data landscape for blockchain data. And he has it broken out by low level infrastructure. And you can click and it'll bring you to all these things and you can look closer. But don't be overwhelmed. Two things is like I want you to look at this and be like, wow, this sector is huge. It is growing by the day. I think when I joined, this would have been a fourth of the size, and it just keeps growing. Decentralized data, but also I want you to actually, I'll send this out, but it is a great resource to be able to reference here all these different APIs to be able to get data from. And this is part of what I was talking about in the first class is that Flipside is fantastic. It has all this good data, but maybe it's not the best resource for some data. And same with Dune. Dune's great, but maybe it doesn't have the best TVL data. That's where going to DeFi Llama, where they have fantastic TVL data. It'll just save you time because they already have it instead of you having to query it yourself. So data warehouses, this is sort of where Dune and Flipside fall into. They have all this on-chain data that you can query. He's got select from. So all of these is what I would say have different data sets, different models. They're all fantastic companies. I've worked with just about, I would say 80% of these. Definitely recommend not being a data warehouse or data provider maxi. Definitely be agnostic here. Index data, we're going a layer deeper here. Enterprise research. These companies, if you end up really falling down the data rabbit hole, these companies put out fantastic free open source research reports. 21 Shares has some of the best on-chain analytics reports that I've seen. Masari is a leader in the industry. Definitely recommend checking those out. Yeah, okay, this list keeps going. I'm gonna stop there and get back to writing the code. All right, I'll send that one out though, guys. Take your time and go through that. All right, we looked at smart contracts being deployed on Ethereum over time. But we want to know how much are people spending to deploy these so that we can see that they're real users, real developers deploying real protocols because they have to spend money to deploy. They're not going to spend $1,000 just because they want to. So let's look at that. What would we do here? All right, I'm going to teach you guys what a CTE is, a common table expression. So to do this, what it allows us to do is basically create multiple tables within one query. And let me get rid of this, guys, make it a little bit bigger. So that we don't have to jump to another query every time we want to do something a little different. But really, ultimately, it'll allow us to create one table, get this output data, and then we can start a whole new table and use this table in it. And it makes your code clean to use. It allows you to take that next step into doing more complex analyses. And then this is also where we're going to use joins. So when you have a CTE, it starts with, and then you want to put an alias. You want to define what this table is. And what we're going to call it is, I'll just call this smart contracts as, okay. And this is all standard kind of formatting syntax that you're going to have to do every time. So every time you create one of these, you start with, define the table name, and then say as, and then put it captured in these parentheses here. Now, if I ran this, it wouldn't output anything because this is sort of like a hidden table. I would have to do select all from smart, gosh, can't type today, contracts. Okay, so what this is doing is saying, hey, create this table, but don't query it. Query it kind of in the background. And then next, what I can do is, then I can query it. But this is just to show you how it flows. In reality, what we're going to do is create a whole new table and call this table that we've created in the background. All right. So the goal here is to understand how much gas is being deployed. So what we're going to do is I'm going to update this. Okay. Sorry guys, I'm going to create a new query. I want to save all these guys so that when you're doing the homework, you can reference back to them. So I'm not going to delete anything that we've worked on. Come on. I do notice sometimes on the flip side it does stall out a little bit like that sometimes. So just refreshing seems to work for me. All right. So to calculate the gas, I really just want to know the smart contract address and the transaction hash that it was deployed. Ethereum core contracts. Okay. Where is create a transaction hash? Okay. So why am I doing this? So ultimately, what I want to do is say, okay, this contract address was created with this transaction hash. I want to know how much gas was spent to deploy that. And I mean, Flipside's fantastic, but it doesn't have all the data in every table. So this just has the transaction or the contracts that were created, the hash, the time, symbol name. It has stuff like that. But that doesn't have anything about gas that was used to deploy this. So where have we learned about gas previously? The raw data, and specifically the transaction raw data. So select and then from transactions. Okay, what type of data is in here? All right, we saw previously that to calculate gas for each transaction, we know that it's the gas price times the gas used. And I think we saw this here. So units of gas used, that's gas used, times the gas price will give us the transaction fee. That's what we want to know. How much did someone pay to launch this? So what I'm going to do is take gas used times gas price. Now, one thing I'm going to do here is gas price is in a unit called GUE, which is 9 decimals off of ETH. So I'm just doing some conversion here. I'm dividing it by the power of 9. So just know all I'm doing is converting it to so that our output is in ETH, so it's easier for us to understand. All right, so if I ran this, just looking at this here, this will tell me the transaction fee for every transaction that ever occurred. That's not what I want. I only want to know the transaction costs for when a smart contract was created. So what do I want to do? I want to say only run this for each created transaction hash. So let's say there were 64 million created transaction hashes. Only run those 64 million. Now, if I ran this without any filters like that, it would run probably billions. I don't know how many transactions there are. We could calculate it, but So we don't want that. We only want it to run the 64 million. How do we do that? Well, that's what we're going to use our join here. What we're going to do is basically take this table and attach it to this by using an inner join. And what is an inner join? There are several different types of joins. There's a left join, right join, outer join. I'm just going to start by teaching an inner join. I would say the most commonly used join is a left join. But we'll start with inner join. Hopefully you guys can kind of understand it. And this is a nice website to kind of help you visualize. So going back here, I'm saying take every transaction that has ever existed and inner join it with just these 64 million that have existed. All right, so let's go look at this. So here's our user table. Let's assume that this is our, I wish I could edit this. This is our contract created table. And then this is our all transactions that have ever existed. When we inner join those, it's only going to output ones where there's existing transactions in both tables. So if one table has all of the transactions, one table only has 64 million, our end result is only going to show the 64 million because the transaction has to exist in both tables. So again, inner joins and joins in general will take a little bit to get your head around what's working, but know that you're taking two tables and you're using a common column to line them up. So here, let's run through this. So we want to inner join smart contracts. Okay, cool. So now I'm saying join these, but I have to say how to join them. And as we've been saying, we want to join them on the transaction hash. So really, I'm going to write this out long form, but I'm then going to show you a way that will simplify things. So join it on this, that's the table name, dot transaction hash. This is the column name. So join it on this table and this column in that table is equal to, now let's take this table, and which column name? We want created transaction hash dot this. Okay, and this kind of seems a little confusing. We can simplify this. We've learned how we can do aliases for column names. We can actually create an alias for a table. So I'm just going to call Ethereum Core Fact Transactions TX transaction. Then smart contracts, I'm going to call SC. So now we have aliases there. We don't have to write this out long form. We can do this. Okay, so it's saying query all the transactions in existence, but then inner join it with just these 64 million transactions and join it on those transactions. So our output will only have those 64 million transactions. And let's just look what this looks like. In the frame, what did I do wrong here? Smart, power. Oh, I didn't write anything there. Explain it. All right, here at line 4. Let's read this. Let's see what's going on. Okay, I changed this code. I never changed this. So let's clean this up. Sloppy on my end. Okay, now this should give us what we want. Yeah, and Andres has a question. An outer join will show everything that doesn't exist. Yeah, it's basically the opposite of an inner join. So if it doesn't exist, output that. We'll talk through left join, which is very similar to what a right join is. So okay, let's finish this up though. So we looked at just 10 random scenarios. This is how much it costs to deploy gas. But in reality, what we want to do is similar to what we did before. We want to do a summation of the gas as transaction fee, and we want to do it over time. Let's do month this time. And we want transaction date. As month. Okay, and then when we do a join like this, anytime we have any filters or anything like that, a group by here, it's after the join. So you always have from, join, and then you'll have your where statement, you'll have your group by statement, you'll have everything like that. Group by date. All right, and I forgot a comma. There we go. All right, this is okay. Yeah, a couple of questions coming in while we wait for this. Yeah, it's okay if you're lost. This is complicated. I'm gonna try and once we get these results, slow it down a little bit. First of all, where does the power 10 lamp come from, and what does it mean? Yeah, while this is running, let me show you. Um, let's go to Etherscan, random transaction. All right. So when we look at the raw data, the gas price is in GUI. And because you can't have decimals on the Ethereum blockchain, there's different. Here, let me uh, GUI versus. Let's see if this shows us a nice table. Not seeing one here. All right. It's just a. I'm blanking on the word for it. Here we go. Okay. So we can see that. Let's go GUI. We can see that one GUI is equal to 10 to the negative ninth ETH. So we have to do a conversion here to get to ETH. Awesome, we got a unit converter here. Yeah. Yes, this is perfect. Yeah. So you can see to get to ETH from GUI, so the units here, you have to divide by 10 to the ninth or multiply by 10 to the negative ninth, which is the exact same thing. So it's just it's a unit thing, a unit conversion. I wouldn't get too hung up on it. It's just if you're diving into gas, it's definitely something you want to know. It's definitely just keeping track of your units while you're looking at on-chain data. Um, most things are need their units converted. So just keep track when you're looking at the documentation on what units something is in. All right. All right. Looks like we ran. Quick graph this bar chart since we're doing month. All right. Okay. Yeah. So we blow this up a little bit. So now we can see actually how much ETH deployers are spending to actually deploy their smart contracts. And we can see during times of April 1st, 2023, people were spending a lot of ETH. And this is total. Maybe we want to look at the average amount spent per smart contract. So, we could do average here. Or we can adjust this. We can play with these aggregates here. All right. But yeah, overall, this gives us a lot better picture of the deployment of smart contracts and how people are spending money basically to deploy these. Now, if I would compare this to Polygon, I think these prices would be a lot lower, and we compare that to the quantity that are being deployed and kind of get a better idea here. All right, and further work, we're looking at this in terms of ETH. We could look at this in terms of USD value. That's further work of like kind of just further analysis work of joining a prices table to this. But yeah, let's. I know we're over the time, and this stuff always takes longer than it should here. I think there's been some good resources shared. Zook shared a nice table here on understanding joins. Definitely take some time to understand these in a little bit more detail. You're gonna see these sort of Venn diagrams of what they're called. And I think it's a great visualization of us understanding. So running through the inner join, um, we see all the transactions that were in table one, all the transactions that were in table two. Only show us the output here, the colored in, only show us the transactions that are in both tables. So here, hopefully that makes sense from the case that we just ran through. A full outer join. Now, if we were to switch our inner join to outer join, it would show all the transactions that are in table one, all the transactions that are in table two. So this would show everything. So we want all the data on both tables brought into one final table. All right, and then left join, we'd want to only see the data on the left table and then merge data from the right table onto our table. And the right join is just the reverse. It depends which order you're putting. I wonder why that keeps timing out. The order you're putting the table here. So, okay, got some more questions. Let's say you want the date to start from December 1st, 2019. Perfect. So all we would do here is we'd run this. We know we have data all the way back until here. Let's process all of this data and then let's filter it. So what we would do is say where, and you can do this is less than, one second, I gotta remember how to define 2023, nope, not 23, 2019, 01, 01. All right, and then we need to define this as timestamp. I have not used Flipside in a while, so this is good. This is practice. So we have to make sure that this is in the same uh, data format as block timestamp. We see block timestamp is in timestamp, so we need to make sure this is in timestamp. I don't know if this is the right way to do it since it's been a long, since the syntax is different than some of the data platforms that I've been using. But let's run through how I would troubleshoot this. Oh, I forgot I edited this. Let's see if that actually is not that. Sorry, we're troubleshooting live here. Okay, so we're saying where the block timestamp is greater than the first here. Now, there's a lot of ways we could do this. We could, here we're using where, and that's basically just saying, hey, don't look at any numbers where the block timestamp is less than that. We can also use a having function, which basically analyzes the data after we've done the summation. And I'll show you kind of how that looks as well. This one's taking a while to run. But anyways, if I didn't know how to do this, what I would go is go to ChatGPT. And so I could either go to the Snowflake documentation or go here and go using Snowflake SQL. How do I convert a timestamp to, how do I convert a, let's say, date to timestamp data type? Let's see what this tells me. Okay, so it looks like we can use this function here. And there's a lot of times more than one function. Let's see if this one works. I wish this query didn't take so long to run. All right, so ChatGPT saying this would work as well. Okay, question. Could you point me to any code base or resource of the DAO that has some example queries to check out? Yes. Let me follow up with that. I'm sure Zook and the rest of the team know a little bit more than me here when it comes to the DAO, but I think they have a lot of really good documentation. you're currently trying with curve pools, but it's not that easy. Okay, I'll reach out to them and see if they have some examples and more specifically related to curve pools. I'll also be sending these out that I have that we kind of went over today so that you can reference those. And this is taking a really long time to run. So Flipside didn't stall out on me. Okay, yeah, I know we're way over time here, and I appreciate everyone who kind of hung out. Let's see if we can get this to run one more time. Yeah. Yep. If anybody got surrounded, this was the end. I'll make sure to get all these out. Last thing I want to say is the homework was due today. I think I said it was due before the start of class. But if you haven't yet, I'll be around today. Zuko will be around as well. If you still have questions and haven't submitted yet, that's okay. Just try and get it in before close of business today. We're gonna take this week to be reviewing and grading those. And then we also have more homework that'll be assigned today based on what we went over today. And hopefully that'll get you guys a little bit more familiar with joins. And then in office hours, I know I wasn't able to talk as much about joins as I wanted. So I'm going to take some time there to go through more detail and then also take a look at the homework in a little bit more detail. So if you guys are a little stuck or anything like that, also, not gonna lie, it's not easy. I notice I get scared whenever I'm about to practice. No worries at all. That is very normal. It is a hard learning curve to get over, and I tell you, just practice, read other people's code, keep looking at it, keep looking at what we went over here, and I promise with you, enough practice, it'll start to click one by one. Um, so yeah, and come to office hours if you can. We kind of just walk through examples and the homework and take it a little bit slower there, and if you got questions. So this is hard. This is not easy stuff. I mean, this is why you guys are here. So do not feel discouraged at all. It took me a long time to get here, and we're analyzing very complicated data that nobody else. There's a very small set of people in the world who can analyze this data. So I think you guys should be proud to kind of even be as far as you've made it here. So yeah, I'll end it there. Oh, actually, it looks like it did run. Let's look at the month. We're only getting 2023. Oh, that's because I put 2023. Sorry, I meant to put uh, the 2018, but this is how you limit it. You could also use halving. We could talk about that in office hours, but I don't want to keep everybody here longer than we're already 15 minutes over. So, okay, I'll get all this out. Appreciate you guys hanging in there with me. Please ask if you got any questions. We got a whole team here to try and help you guys. So, cool. Awesome. Thanks, everyone. Enjoy the rest of your day. We'll see you soon.